Hi everyone, it's Mr. Campagna. Today we're going to be taking a look at some subatomic particles and how those subatomic particles give protons, neutrons, and electrons their charge. So who says scientists don't have a sense of humor? Look at the odd names and images in the chart. Any idea what they represent? Would it surprise you if you learned that they represent most of the fundamental particles of matter? In fact, particles with funny names like charm quarks and strange quarks make up all the matter in the universe. So scientists have long wanted to find the most basic building blocks of the universe. They asked, what are the fundamental particles of matter that cannot be subdivided into smaller, simpler particles? And what holds these particles together? The quest for fundamental particles began thousands of years ago. Scientists thought they had finally found them when John Dalton discovered the atom in 1803. The word atom means indivisible, and Dalton thought that the atom could not be divided into smaller, simpler particles. For almost 100 years after Dalton discovered atoms, they were accepted as fundamental particles of matter. But starting in the late 1890s with the discovery of electrons, particles smaller and simpler than atoms were identified. Within a few decades, protons and neutrons were also discovered. Ultimately, hundreds of subatomic particles were found. Today, scientists think that electrons truly are fundamental particles that cannot be broken down into smaller, simpler particles. They are a type of fundamental particle called leptons. Protons and neutrons, on the other hand, are no longer thought to be fundamental particles. Instead, they are now thought to consist of smaller, simpler particles called quarks. Scientists theorize that leptons and quarks are held together by yet another type of fundamental particle called bosons. All three types of fundamental particles, leptons, quarks, and bosons, are described on this slide and the next. The figure to the right shows the variety of particles of each type. There are 6 types of quarks. In ordinary matter, virtually all quarks are the types called up and down quarks. All quarks have mass, and they have an electric charge of either positive 2/3 or negative 1/3. For example, up quarks have a charge of positive 2/3, and down quarks have a charge of negative 1/3. Quarks also have a different type of charge called color charge, although it has nothing to do with the colors that we see. Quarks are never found alone, but instead always occur in groups of 2 or 3 quarks. So there are also 6 types of leptons, including electrons. Leptons have an electric charge of either -1 or 0. Electrons, for example, have a charge of -1. Leptons have mass, although the mass of electrons is extremely small. There are 4 known types of bosons, which are force-carrying particles. Each of these bosons carries a different fundamental force between interacting particles. In addition, there is a particle which may exist called the Higgs boson, which gives objects the masses they have. Some types of bosons have mass, others are massless. Bosons have an electric charge of +1, -1, or 0. Question. Protons consist of 3 quarks, 2 up quarks and 1 down quark. Neutrons also consist of 3 quarks, but this time it's 2 down and 1 up. Based on this information, what is the total electric charge of a proton or of a neutron? So a little bit of simple math is required for this. So our first one, let's do for a proton. So a proton, it is made up of 2 up quarks and 1 down quark. An up quark, as you can see from the chart, has a charge of positive 2/3. So we're going to add 2 positive 2/3. Then it has a down quark, and the down quark has a charge of negative 1/3. 2 plus 2 is 4, plus -1 would be 3. That gives us a charge of positive 3/3, which equals 1. So a proton has a positive 1 charge. But let's do the same with the neutrons. Neutrons are made up of 3 quarks as well, but this time it's 2 down quarks and 1 up quark. Now the down quark, let's write this down, 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 up. The down quarks have a charge of minus 1/3. So each one of these would be minus 1/3. And the up quark has a charge of positive 2/3. So minus 1 plus minus 1 equals minus 2. Minus 2 plus positive 2 equals 0/3. Well, 0/3 is the same thing as 0. So in this case, neutrons have no charge. These combinations of quarks give protons a total electric charge of positive 1, which is 2/3 plus 2/3 minus 1/3, giving 1, and neutrons a total electric charge of 0. 2/3 minus 1/3 minus 1/3 equals 0. So it's as simple as that. These fundamental particles contain charges which, when added to the other subatomic particles that make up things like protons and neutrons, can give the proton or neutron its charge. I hope this was helpful. Thanks for watching.